So constant of inverse variation. So when we have things varying, we use k, and if it's jointly, then the variables are multiplied by k. Variables are multiplied by k. If it's inversely, though, if it varies inversely, then the variables are divided. So, for example, if x varies jointly as y and inversely as z, and x equals 18 when y equals 12 and z equals 2, find x when y equals 75 and z equals 15. Okay, so this is saying x varies jointly. So x is k jointly, so times y, and inversely, so divided by z. So this is kind of my setup of my relationship between x, y, and z. So when x is 18, y is 12, and z is 2, which instead of z I can plug into, I need to find k. So right now I've got 18 equals k times 6. So k equals 3. So my relationship is that x is 3y divided by z. So now I can find x when y is 75 and z is 15. So 3 times 75 divided by 15 is actually 15. So x will be 15. So we can see, we wouldn't really be able to see that relationship just looking at the initial problem too easily. Okay, so how about a more applied problem? So for this one, we've got a horizontal beam. A horizontal beam supports a load P. So it's like probably P for the pounds, the weight that it can handle. So a horizontal beam supports a load P that varies jointly as a product of the width W of the beam and the square of the depth and the square of the depth D, and inversely as the length L. Which, if we think about this for a second, it kind of makes sense. A beam, the weight that it can handle, if it's wider and deeper, it can handle more load. But the longer it gets, the less it should be able to support. The longer the beam, without the supports under it, the less that the load could handle. So that's why it's inversely as L. Okay, so a beam, so let's put in some numbers to this. A beam has a width of 5 inches, depth of 12 inches, and length of 8 feet, and can safely support 1,260 pounds. determine the safe load safe load the beam can handle if it's 20 feet long. Okay, so let's go back to the beginning. So the beam supports a load P that varies, so P equals, I'm going to need a K jointly as a product of the width and the square of the depth. So K times W times D squared. And inversely as the length. Okay, so that's all, I got all my variables there. So a beam has a width of 5, so I'm not going to know K. Width is 5, depth is 12, and the length is 8 feet, and it can support 1,260 pounds. Which in this case, I'm kind of mixing inches and feet, but as long as I'm using the same units in the other part of what I'm trying to figure out, it should be okay. So 1260 equals, so if I simplify all this, 5 times 12 squared is 144, divided by 8, that'll be 90K, divide, and I'll have K equals 14. So that means P equals 14 WD squared divided by the length. So with the situation I'm trying to figure out, determine the safe load that it can handle if it's 20 feet long, we'll have 14 times 5 times 12 squared. We're assuming it's the same type of beam, but now it's 20 feet long. So when I calculate that all, I get 504 pounds, which makes sense because we said the longer the beam is, the less it should be able to handle.